form which is called as a normal form. So before that, we will see one result, invariance of rank. Invariance means no change. Invariance of rank, still students are admitting the class. Aditya Patil. Yeah. Invariance of rank through elementary transformation. Through elementary transformation. Okay. So within 2 days, I will share the notes. You can take a running notes, whatever I'm teaching. Okay, printed notes I will provide in the Google Classroom or by Moodle. Okay. Now, suppose I think 53 students. Now listen carefully. Suppose A is a given matrix of order m by n. Okay. So number of rows in the matrix A equal to m, number of columns of a matrix A equal to n, and it is given that rank of matrix A is R. Okay, this is a given part. Now from a matrix A, suppose you are obtaining a new matrix which is called as a B. They may not be equal. So how you are obtaining a new matrix? By applying a sequence of elementary transformation on a matrix A. You are applying elementary transformation on a matrix A. That elementary transformation includes row transformation and column transformation, both. Okay, where once again I repeat, A is any matrix of order m by n, and rank of A is R, and from this matrix A you are obtaining a new matrix B which is equivalent to A. We use the word equivalent, not equal. Equivalent to A or equivalent to A. And how you are obtaining this matrix B? By applying a sequence of elementary transformation. That means that elementary transformations may have 1, 2, 3, 4 like that. Any sequence of elementary transformation on a matrix A. In that case, we write these two matrices as equivalent, and we use a symbol to write equivalent matrix as A is equivalent to B. Don't use equal sign. Okay, don't use equal sign. Again, I'm telling this because most of the students, they are using equal, but you have to use the equivalent sign. Then what is the rank? That theorem says that rank of the new matrix is also equal to R. That is, rank of the matrix A is equal to rank of the matrix B. So in short, what this theorem says here, suppose two equivalent matrices are given, then their rank is same. In short, if the two equivalent matrices are given, then their rank is same. In other words, suppose you are obtaining a new matrix B from a matrix A by applying a sequence of elementary transformation, then the rank remains same. So rank is invariance under elementary transformation. Okay. So for example, so I will take yesterday anyone can recall yesterday first matrix? Yeah. Yesterday first matrix. So let A is equal to first matrix. Anyone?
2, 4, 1.
Yes, 2, 4, 1.
3, 6, 2.
3, 6, 2.
4, 8, 3.
Once again, you can repeat.
4, 8, 3.
Yes, 4, 8, 3. Okay, this is the first example. We have obtained rank of this matrix by using definition. And rank of A, yes, Sankalp, quick, unmute and tell. What is the rank yesterday you obtained?
3 by 3.
2.
3 by 3 you are telling. 2, na? Rank is single integer. Rank is
2.
Okay. Now see what I will do. This is the given part. Now here I'm not finding the rank, I'm using the statement of that above. So here I will apply the elementary transformation. Suppose R3 minus 2R1. So what this shows, this elementary transformation shows that change in third row, change in third row. So that's why I will write, you will get a new matrix which is equivalent to A. Don't use equal sign here. I'm using equivalent, okay? So the new matrix only change in the third row. First row, 2, 4, 1 remains same. Second row, 3, 6, 2 remains same. Now apply the elementary transformation. What you have to do? You have to multiply first row by 2 and their subtraction. Now tell me, 4 minus 4. Correct? Can anyone tell? 8 minus 4 into 2. What is the last element? 3 minus 2.
2.
Right?
1.
1. 3 minus 2, 1. Okay. So this is a new matrix. Suppose one more elementary transformation I will apply. What that transformation is? Suppose 2 multiplied by R2. That means I am multiplying second row by R2 and first row by R1 and their subtraction. Okay. So for your understanding, I will do the calculations here. 2R2 is multiply second row by 2. 3 2s are 6. 6 2s are 12. 2 2s are 4. Correct na? Multiply first row by R1. 3R1. That becomes 3 2s are 6. 3 4s are 12. Is it right? 3 1s are 3. Okay. And their subtraction, that is the resultant element. 6 minus 6. 12 minus 12. 4 minus 3. So the resultant row is given by. That means you are changing here second row only. Okay. Change for the second row. You will get a new equivalent matrix, where first row no change. First row no change. That means 2, 4 and 1. Now second row you have to change by, this is a new R2. What are the elements? 0, 0, 1. Now again third row no change. 0, 0, 1. And suppose this is a matrix B. Further you can apply elementary transformation. So the new matrix you are obtaining from a given matrix by applying sequence of elementary transformation. That sequence having, the first one is R3 minus 2R1. Second one is 2R2. For first example, I may write, you are changing R3 as. So here you are changing R2 as. Okay. Now in this case, by the definition, first I will write here A and B. So here the matrix A and B are equivalent. Okay. The matrix A and B are equivalent. That is the equivalent sign. Don't write A equal to B. I am using red. That means danger. This is not correct. Okay. This mathematically don't have meaning, because you know the definition of equivalent matrices. Anyone can recall? Manjit, what is the definition of equal matrices? Manjit Patil. Be fast, Manjit. Joshi, Indranil Joshi.
No, sir.
You don't have you don't recall definition of equal matrix?
No, sir.
Okay. Now next one, Vaibhav Devkate. Now see, when you see the recording now, if you go through the recording of this classroom, whoever is talking now, the screen with their name or photo will come. If you are giving the answers, then your name and your photo will come there. So generally teacher is talking, most of the time teacher will appear, but when you are telling the answer at that time, your photo will be there if you are using video. Otherwise your name. Indranil,
Yes, sir.
What is the definition of equal matrix?
Both matrix are same.
म्हणजे काय? What is the order? Okay, one by one. Indranil, you have to tell the answer. Equal matrix means first they should be in terms of order. त्याचा order कसा असणार? Okay.
Order
Here,
same.
order same. Suppose A is a matrix of order m by n, and suppose A is equal to B, then B also having the order same. Is it clear? So whatever I am writing on the screen, that is clearly visible, na?
Yes, sir.
Okay, fine. That is the first condition. Okay, they are of the same order. Second condition, Aij म्हणजे त्यांचे प्रत्येक element, they are having element Aij is equal to Aij, suppose Bij. Okay, A for first matrix, B for second matrix. Aij is equal to Bij for all I and J. म्हणजे काय? समजा हा 1 2 3 4, this is the first matrix A, then B also the same 1 2 3 4, then only we can say A is equal to B. They are having the same order with the same element. Is it clear? But
Yes,
in case of a equivalent matrix, what is that? Order is same. Order is same. If here A is a matrix of order, yes, A is a matrix of order 3 by 3, B is a matrix of order 3 by 3, but elements may not be same. Okay, elements may not be same. Now it's clear, na?
Yes, sir.
There is a difference in equivalent and equal matrix. So this is a definition for equal. So you have to use this notation to denote equivalent sign. And when we say the two matrices are equivalent, then their rank is same. So thus, what is the rank of the matrix B? Yes, anyone? Anyone? Initially, we have started. Yes, we have started that rank of A is 2 here. If rank of A is 2 here, rank of yes, fine. एकाने दिलं की immediately stop करा. Okay, rank of A is 2. So we have started rank of A is 2 and A and B are equivalent. So we can write directly rank of B is also 2. That means, so next onwards, we are going to use the property of that equivalent matrices to find the rank. And we use a new definition which is called as a normal form or first canonical form. So this is important. Mostly if you go through the question paper, so examples will be asked on to find a rank by using normal form of a matrix. Okay, I will explain the definition. Suppose A is any m by n matrix and rank of A is equal to R. Okay, first try to understand the definition. I have started with A is any rectangular matrix. That means m is not equal to n. Then this matrix, from this matrix we are obtaining a new matrix B which is equivalent to A. Okay, here this A and B are equivalent. Means what you are doing? You are obtaining this matrix B from a matrix A by applying elementary transformation. So that elementary transformations include row as well as column. But particularly this matrix B can be reduced to the form where, so here I will write, where the matrix B can be reduced to the form IR 0 0 0. Means what? These are the block matrices. So there is a unit matrix of order R and remaining elements are 0, or this can be reduced to the IR 0, or this can be reduced to the IR 0. Okay, so what is the meaning of this? Suppose Suppose I will consider a matrix A is equal to general matrix. I will consider first row A11, A12 dot dot A1n. This is the first row. Second row A22, sorry, A21, not A22. This is A22 dot 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 A2n. Now continue. Suppose the last row is given by AM1, AM2 dot dot AMN. So this matrix is of order m by n, and rank of the matrix A is R. So what first thing while solving the example, you have to fix the diagonal entry of this matrix. Even we are talking diagonal entry for a square matrix only. If it is a rectangular, we can consider A11, A22, A33. These are the diagonal elements. Okay. Now this matrix can be reduced to the form. Yeah, I have to use this plan. So you have to apply elementary transformation on a given matrix A, a sequence of elementary transformation such that this matrix will reduce to the 0, 1, 0, 0, dot, dot, 0, 0, 1, 0, dot, dot, dot. So like that you can continue 0, 0, 1, dot, dot, 0. Continue. The last one is 0, 0, 0. So the same thing you can write. This is an equivalent matrix. Now this matrix I will denote as what happened? There will be, so here it is difficult to generalize because I have taken. So here I will consider this as unit matrix of order R. That is a first block. Okay, I'm using same color. So that I will write as IR. Now the next one, this one. This is nothing but zero matrix, null matrix, and this matrix is denoted by capital O. Okay, so this matrix is denoted as a capital O. And next one, suppose this one is again you are having a zero matrix, and this is nothing but this 0. So this is a 0, and last one finally, this one is again a 0 corresponding to this. Okay. So that's why I'm using purposely that vertical and horizontal lines. Okay. So in this case, rank of the matrix is nothing but whatever unit matrix of order R you are getting, this one. So rank of the matrix is R. Now it may possible that this matrix can be, suppose up to the last that 1 1 1 is present, that matrix we can write in IR0. There is a no block matrix. Means suppose अगर आपको last row तक आपको 1 मिल रहा है up to the end, in that case you are having this representation. Or suppose when you are representing like this ना, आपको अगर last column तक अगर आपको 1 मिल रहा है, in that case we may write this as a IR0. So depending on the final matrix, you have to decide the notation. So after converting to this, you can recognize what is the rank of the matrix. So this definition we are going to use to find a rank of the matrix. In reverse way we will go. So when the question is to find a rank of the matrix, we will reduce that to the normal form. Okay, we will reduce that given matrix to the normal form. After reduction of the matrix, we may write that matrix to, depending on the present elements, to the first form or to the second form or to the third form. And from that, whatever value of R is there, that is nothing but the rank of the matrix. Any doubt? Is it clear? I will take one example. Again, you will get more clear idea. So, for examination point of view, the question for examination will be like this. define rank of a matrix if the definition is there. Otherwise, reduce the matrix to the normal form and find its rank. That question I will consider common. I will start. Actually, your syllabus started. This one, I will write a common question. For questions, I will use green color. Determine the rank of the matrix or reduce the following matrices. Simultaneously, you can take down. Reduce the following matrices. First example, you have to listen carefully. And if any doubts are there, we can discuss during solving that example. Second onwards, you can solve simultaneously. So first, I will complete the example and then you can take down. I will give extra timing for that. Is it clear? Okay. So I will denote the given matrix as A. So let A is equal to the given matrix. A is equal to given matrix 1, 3, 4, and 3. 3, 9, 12, 3. 1, 3, 4, 1. So what is the order of the matrix? What are A? What is the order of the matrix? Simple questions I'm asking. So if you reply
3 cross 4.
3 by 4.
3 by 4.
3 by 4. Okay. 3 by 4. Now next, a question which having somewhat difficulty level high. What is the greatest possible? I'm using the word possible. What is the greatest possible value of rank in this case?
3.
Correct.
3.
Yes, exactly. 3. Now I will generalize. If A is a matrix of order m by n, what is the greatest possible value of rank here? Greatest possible rank, I am using the word. Here 3. Now can you generalize, because for multiple choice questions, these are important. How you are getting 3 here? The answer is in terms of m.
That-
The answer is in terms of m. Manjit.
We should take first 2 rows, then from that 2 columns and solve. Na? And if it
No,
comes
no, no.
0, it is.
No, it is difficult to apply the definitions henceforth. That's why we're using a normal form. The answer is in terms of m and n. Here 3 and 4, the answer is 3. Like that. Why you are taken 3? That looks 3. So maximum you can select 3 rows, 3 columns. That's why the greatest possible value of rank is 3. Likewise, what is the greatest possible value of rank if A is m by n? Your answer may be wrong, you can tell. You can tell the answer. Yesh Khade says yum. Okay, next. Yesh Khade says that yum. Okay, for your understanding, I will write one more matrix. Suppose A is a matrix of order 1, 2, Wathare also says yum. Okay, 1, 2, 3, 4, 1, and 2. Now in this case, the order of the matrix is 3 by 2. What is the greatest lower number from m and n? Correct, Yogesh. So you have to take lower means you have to use the minimum word. Minimum of m and n. In this case, the greatest value, possible value is 2. Okay. So minimum of m and n. Is it clear? Minimum of m and n. If A is a matrix of order m by n, then greatest possible value of rank is minimum of m and n. Not to find, don't write anything, see screen carefully and help me to complete the example. When the matrix is given, first fix the diagonal entry for the given matrix to reduce the matrix. Okay, so to reduce the matrix to the normal form means what is our general form? You have to consider a new matrix where the diagonal elements are 1 and all the non-diagonal elements should be 0. And J Kai 1 NRI, that should be there at the beginning, and later on you can join the join. First start with 1, 1, 1, 1 and then 0, 0, 0 like that. So this is our target. So according to our target, we are focusing on the diagonal elements. That's why I will fix diagonal entry. So even this is a non-square matrix, I will consider A11, A22, A33 as the diagonal entry. Is it clear? That means the elements 1, 9, 4 are diagonal elements. After that, what is our target? So first try to obtain A11 element as a 1. A1 element as a 1 without getting fraction. Try to avoid a fraction. If you are getting a fraction, try to avoid. So if you are getting fraction, then also it's okay, but calculation may go wrong. So that's why try to avoid fraction, and by avoiding fraction, obtain A11 element as a 1. Now for our example, A11 element is 1. Already you are having that one. The first target is fulfilled. After that, fix the elements which are below to A11. Means what? These. So these elements you have to reduce to 0. Same color I will apply. By applying row transformation. It is not a mandatory. Okay. It is not a mandatory. Means what? I will consider that A11 element to reduce these two elements as a 0. Can you tell what are the elementary transformation to reduce this element to 0? This element means what? R2. Okay. R2. What is your elementary transformation? You have to use the round number.
R2 equal to R2 minus 3 R2.
Okay. In chat box, most of the students they are writing R2 minus 3 R1. Correct. Okay. So simultaneously, suppose you want to reduce this element to the 0, then you have to use this round element only and don't use R2. Don't write. First listen. Take a time. Yes. R3 minus R1. Okay. These two elements shows that change for what? Second row and third row. Second row and third row. And you are getting a new matrix which is equivalent to A. Don't write equal sign again and again. I am telling. Equivalent to A. Equivalent to A. So the new matrix where first row no change. That means 1, 3, 4, 3. First row no change. Now the next one. For first example, I will consider these separately. So your R2 is, here I will write. Sorry. I will use a different color for calculations. So okay, red only I will use. R2 row you have to write as it is. R2 row is 3, 9, 12 and 3. Now the next one, you have to multiply by 3 to the first row. What are the resultant element? 3 ones are, 3 threes are, 3 fours are. You are multiplying by 3. What is the last element? Quickly. 9. Okay. And their subtraction. 3 minus 3, 0. 9 minus, if required, you can write minus. 12 minus 12, 0. 3 minus 9. Is it right? So the second row can be written as 0, 0, 0 and minus 6. Similarly, so directly orally we can complete this subtraction. 1 minus 1. 3 minus 3.
0, 0, 0, minus 2.
Minus 2. Okay. By applying these two elementary transformation, you are getting a new matrix with these elements. Once again, always up to the end, we have to stick with the diagonal entry. This one. This one is the diagonal entry. So after getting, and you obtain this A11 as a 1. After getting the elements which are below to A11 as a 0, immediately, these are the standard practice or methods to operate the matrix. Okay. After getting the elements which are below to A11 as a 0, immediately you have to reduce the elements which are write to A11 to 0 by using column transformations. So whatever I have circled in the second matrix, so that elements you have to reduce to 0 by using a column transformation. Now, the elements 3 corresponding to the second column, that's why I will write C2. And you have to use first column to obtain that element to 0. Can you generalize or can you guess the transformation?
C2 can be changed to C2 minus 3C1.
Correct. C2 can be changed to the C2 minus 37. Okay, I am writing the transformation like this only. You can use C2 dash like that. Similarly, next transformation, this element suppose you want to reduce to 0, that is corresponding to the third column. Yes.
C3 minus 4C1.
Correct. Now corresponding to this.
C4 minus 3C1.
C4 minus 3C1. Now once again you are getting a new equivalent matrix to the given matrix. Okay, just I will use new equivalent matrix to the given matrix. So apply the elementary transformation. Now in this case, I am applying row transformation. That's why, sorry, I am applying column transformation. That's why I will write this matrix column wise. So in these three transformations shows that change in the second column, change in the third column, change in the fourth column. Okay. First column, no change. That means 1, 0, 0. Tell me, if you multiply this row by 3, for your understanding, I will write multiply by 3 by this column. That becomes 3, 3, 0, 0, 0, 0. What is the resultant?
Zero,
Correct.
zero.
Both are identically same. So the resultant column is 0, 0, 0. Now applying column transformation. That's why I'm writing column wise. So the next one, multiply by 4 for the next transformation. Multiply by 4 and their subtraction. What is the resultant?
0, 0, 0.
0, 0, 0.
Correct. Now the next one, multiply by 3 na? Multiply by 3 and their subtraction. Now tell me.
0 minus 6, 0.
0, sorry, same color I am using. Sandesh Pargaonkar just
0 minus 6 minus 2.
correct. 0, 0, minus 6 and minus 2. Now again, your diagonal entry, you are getting a new matrix. Now in this case, this is your diagonal entry. So normal form means what? You have to reduce the matrix to the form where diagonal elements are either 1 or 0 and non-diagonal elements should be 0. So what is your suggestion next? You can use the word by for applying transformations, by applying these transformation. Yeah. Okay. So what I will do, I will try to convert these two elements as a 1. So for that, I will multiply minus 1 upon 6 into R2 and minus 1 upon 2 into R3 because only one non-zero element, only one non-zero element, only one non-zero element, I will multiply by its reciprocal. Now you will get new equivalent matrix. Now you are applying a column transformation. That's why you have to represent or you have to write a matrix. Sorry, you are applying a row transformation. You have to represent or you have to write a matrix row wise. So these two transformations shows that change in second and third row. First row, no change. 1, 0, 0, 0. 0 multiplied by anything, you will get 0, 0, 0. Minus 1 by 6 into minus 6.
1.
Similarly, third one, 0, 0, 0 and 1. 0, 0 and 1. Now, this is your diagonal entry. So, according to the normal form, diagonal elements I required as either 1 or 0. Non-diagonal elements should be 0. That means if it is possible, try to reduce these 1 to 0 if possible. Otherwise, so try to fix these elements to the diagonal entry. What is your suggestion here?
Changing columns.
Yeah, I will try to shift this one to the A22 position. So for that, what you have to do? By interchanging column numbers, tell me. By interchanging second and fourth column, correct na? Interchange second and fourth column, you will get a new matrix. Now you are applying column transformations. You have to represent or you have to write that matrix column wise. Change in second and fourth column. First column, no change. 1, 0, 0. Now, fourth column becomes second. That means 0, 1, 1. 0, 0, 0. No change. And this second becomes fourth. This second becomes fourth. 0, 0, 0. Now this is a matrix once again. Now in this case, this is a diagonal entry. This is a diagonal entry. So by the definition, first condition is fulfilled. The diagonal elements are either 1 or 0. Okay, that is true. But there is a one element which is not equal to 0. There is a one element which is not equal to 0. So the general procedure is, so whatever you did for A11, the same thing you have to do for A22. Fix A22 and try to obtain that element as a 1 that is already there. And by using this element, reduce this element to 0. What is the transformation?
R3 minus R2.
R3 minus
Yes, R3 minus R2. So this transformation shows that change in third row. So the new equivalent matrix where first two rows remain same. There is no change. That means 1, 0, 0, and 0. Second row also no change. 0, 1, 0, 0. Now I think these are the same rows. And if you take a subtraction, 0 minus 0, 1 minus 1, 0 minus 0, 0 minus 0. So this one. Again, fix the diagonal entry. This is your diagonal entry. So for a normal form, in short, how to remember? For the normal form, the given matrix can be reduced to the form where all the diagonal elements are either 1 or 0. The condition is satisfied. In this case, all the elements are 1 or 0 and the non-diagonal elements are all 0. So further it can be classified or we can consider a block like this. Block like this. This is a matrix. And this matrix we will represent as, this is a normal form. So how to represent? This is a unit matrix of order 2. So for that I will write I2. Correct? I2. Now this is a unit matrix of, sorry, this is a zero matrix, whatever the order. And zero matrix is generally denoted by capital O, capital O, capital O. Okay, zero matrix or null matrix. And the blocks of the matrices are like this. So this is a normal form. So after getting the normal form, what is the rank? Hence, rank of the matrix A is 2. Is 2. Okay?
2.
Correct. So this completes the example. If any doubt is there, we can discuss. Are still joining the students is almost 12:35. That is a problem. Okay. Any doubt is there? You can take down. You can take down. You want to write, you can write. Otherwise, you can take a screenshot and afterwards you can complete. The same thing, whatever I am explaining, that can be converted to the PDF and that also I can send to your WhatsApp group. It is better to send that notes to the WhatsApp group.
Yes, sir.
Yes, sir.
Yes, sir.
Just I will convert it. Microsoft to PDF. Yes. FY BTech Division C.